Okay, yeah, sounds good. Okay, so it's a pleasure to be here and to talk to you about what's coming up in the next generation of the Spring Framework. So we'll talk a lot about what we've done in Spring Framework 6 and what are like the main features. And as you'll see, it's not only about Spring Framework, that's also about Spring Boot. Spring Boot also has a... Oh boy. That was me, sorry, clicked the wrong button. We'll cover a bit of Spring Boot 3 as well. Okay, so let's have a look to what we're going to cover tonight. There's some words about support timeline. New generation means that you need to upgrade and you also need the time to upgrade. So we'll talk a bit about how much longer the current generation will be supported. Talk about a bit of the baseline upgrades, as new generation means that we can make some adjustments in terms of system requirements and stuff like that. And then we'll cover a number of new main features, observability, the problem meters, RFC. The big one is AOT ahead of time and native support. So we'll spend a bit more time on that, and we'll conclude with Java interface clients. Okay, so let's talk a bit about the support timeline. So this is where we are at the moment today, with Spring Framework 5.3 being the current generation, and 6.0 is about to be released. So this is the blue line you see at the top. It's like not yet available, but it will turn green once it is, green and yellow. So you can see that the support for the 5.3 generation has been extended. So that's the yellow line you see in the middle there, up to 2027, well, actually the end of 2026. So we give you more time so that you can upgrade your applications, take the time to upgrade your application and also get support on the current generation. We expect, as usual, that once you jump to the next generation, so 6, you're not stuck on 6.0 for too long. So once you're on 6.0, you go to 6.1 and then 6.2, etc. So you follow the release train, as it was the case for 5.3 for the current generation. Sorry. Oh, I forgot to mention that the green thing, that's the open source support, and the yellow is the commercial support. So the commercial support obviously is longer. So what's going on for Spring Boot? Spring Boot is also extending its support. You can see that the second yellow line, that's longer than usual. So 2.7 will be supported up to when 3.1 is released, so you get more time to upgrade. You can already, although it's a bit close now with the 3.0 GA, 6.0 GA happening next month, as we will see in a minute. But you can already prepare your applications for the next generation today. So there's a few more steps that you can apply on the currently supported generation to prepare your applications to the upgrade. One is, if you haven't done so, is upgrade to the latest Spring Boot 2.7. So at the moment we are at 2.7.5, so upgrade to that, please. If you're in 2.5 or 2.4 or something like that, please make sure to upgrade one generation at a time. So don't go from 2.4 to 2.7. Go to 2.4 to 2.5, 2.5 to 2.6, 2.6 to 2.7. And each, what we call feature release, so that's the middle digit in the release numbering. Each feature release has a migration guide, so that's the link on the top. I'll share the slide with you after. Once you're on the latest 2.7, upgrade to Java 17. You can use Java 17 today with the current generation. So please don't wait for Spring Boot 3 to use Java 17. Upgrade right now if you can, because if you've done those two, you're already quite close to the target. Some cleanup in your apps, so you can check deprecations in code and in your IDE. configuration properties that has like deprecated tags. Some properties are moving. Sometimes a property is deprecated in favor of something else. Your ID should tell you what those are. And if you don't have an ID that has Spring support, you should, but in case you don't, there's also the properties migrator you can use. So it's a small library you can add to your app, and when you start it up, it will tell you if you're using any deprecated property. There's a few more steps you can follow in that blog post. So that's mostly about a deprecated configuration properties binding or anything that we've kept in 2.x, not to break you, but we've definitely removed in 3.0. So if you rely on that, you'll need to upgrade to the supported system first. And that blog post has like anything I've explained here, plus a few more tips. All right, so let's talk about the Java baseline upgrade. The reason why you need to upgrade to Java 17 ASAP is because the next generation requires Java 17. So you can't use Java 8 or Java 11 anymore. You really need to jump to the current, what we call LTS. And that has caused a bit of confusion when we announced that last year. So I want to get back to a bit of a timeline and what happened. So if we look at last year when we announced that Java 17 would be the default for the next generation, Java 17 was out like a few weeks after we did the announcement, so it was really close. Then we started to work on milestones, the first one in December last year. In the meantime, we already have Java 18. Then we've actually, those slides are a little bit outdated because the RC was last week, right? So this is release candidates was done last week. We have Java 19 in the meantime. And the GA, as I've mentioned, is scheduled for late November. So next month, there's probably 3 weeks left or something like that. And yeah, and Java 20 is already almost there by that point. So I guess what I'm trying to say is that Java is moving really fast now, and they release quite frequently, actually as frequently as we do. And so keeping a very long supported range of generation was not the right call, I think. We also build everything on every commit on multiple JDK just to make sure everything works properly. So that's for the main build, but for the current generation build, we build with 8, 11, and 17. So that's the first baseline upgrade. Java 17 is now the default, so you need to make sure you upgrade to that. The other one, which can be also quite problematic, is the Jakarta EE move. So moving the baseline to Jakarta EE9. If you don't know about this, that's the move from Java EE to Jakarta EE, and that led to migrating the package imports from JavaX to Jakarta, which means everything is broken. If you don't do that, you can just change one and not the other. You have to move everything. And we really had one shot at doing that properly. And of course, a new major generation, is the right way to do it. So we've been working with the community, making sure that open source libraries are compatible with Jakarta. It wasn't the case. So when Milestone 1 was released, there were a bunch of features that we had to remove from Spring Boot because they were not ready yet. We were Jakarta E compatible, but the libraries were not. And so we worked with the community and making sure that those are upgraded. And we are in much better shape now with all those features being restored, I believe. Yeah, all of them, maybe one or two are missing that I'm not aware of, but most of them are. And if you use Spring Boot dependency management, that's another strength of using the BOM is that it will make sure that you don't get any JavaX-based dependency in your build. It will make sure to exclude them, and it will bring only the Jakarta one. So if you upgrade to, let's say, RC, to 9 because you want to try it out on the next day. And some dependency don't seem to be managed anymore. So you say, oh, there is no version number for this. It means that you probably need to change the coordinates because of those major moves, some open source libraries, they've also decided to change the Maven coordinates. And so the previous coordinates, which are JAVAX based, are not managed anymore on purpose. So pay attention to that. You may need to add a classifier or change the artifact ID in some cases. And the migration guide should give you some information about it. Okay, so that's really the first big thing, the baseline, Java 17, Jakarta EE9. It's also very important to note that open source libraries, they won't be releasing a lot of new feature release based on Java Enterprise Edition, so the JAVAX namespace. So for instance, Tomcat, Undertow, Jetty, or any open source library that rely on those APIs, the Java EE version, the JAVAX version won't be maintained much longer, right? So you really need also to upgrade for that reason, because then you'll get the new generation of those libraries. The next topic that we've been working on is observability. So if you look at what we have at the moment, we have Micrometer, which provides support mainly for metrics. I'm talking about the current generation. And we had also a separate project called Spring Cloud Sleuth, which provides tracing, distributed tracing support. And it was a bit of a, it wasn't really integrated within a single umbrella. It was like different projects with different objectives and also different configuration model. And we've decided to really bring that back into something that's more coherent. So there is mainly 3 ways that you can see to observe your application or to basically instrument your application. And I got the lead of Micrometer here, so I'm afraid I'm going to say something stupid. So there are 3 things. You can use a Java agent, right? And you look really at manipulating the bytecode and having the agent providing metrics and traces for your code. You can use public extension points. So that basically means whatever you want to observe, you add interceptor, filters, customizer, or some kind of callback API that then the API can use to hook into it and provide the necessary infrastructure. So the second one is what we use at the moment in the current generation. And it has some issues because if you want to observe something that wasn't meant for, you need to sometimes expose a public API, but maybe you don't want to expose a public API for this. Or maybe the API is not, let's say, does not provide enough coverage of what you want to do with whatever metrics you want to expose. So it's been a bit problematic. Or the third option is to instrument the library directly. So essentially, you move the responsibility of providing metrics and traces in the library itself. So the library itself decides how to do it. They doesn't have to expose anything in public, and it can improve it when the API needs to change. So it's much more coherent this way. And the next generation is using the third option. So there is a new observation API coming with Micrometer 110. It's a very thin, very lightweight jar that becomes mandatory in some of the dependencies, and the dependencies themselves use it to provide metrics. The other advantage is there is no longer like a distinction between metrics and traces. It's like in the next generation, everything is built in. So you get metrics and distributed traces as we will see. So that from if you've been using Micrometer in the past, you can get all kinds of metrics and dashboards and whatnot. What's new is that out of the box, you also get distributed tracing now and more correlation. So you can essentially much more easily add that kind of feature to your app. The framework Spring Framework 6 is using this new observation API for everything that's HTTP related. So the client and the server is covered. Not all features in Spring Frameworks are covered, but we are still working on adding them in the coming months. Let's say you want to create your own observation because whatever API you have needs to have some kind of counter or some kind of, something you want to observe. So this is an example of this new observation API where you can, the interesting bit is everything is interesting, but the more important bit I would say is the observe Lambda block. So what's happening is within the Lambda block, it will time the invocation. Because you're using REST template, it will automatically share the context ID. So the context ID will be available on the server that's responding to that devox.be service. So everything will be, everything related to that request will be linked consistently. And then you can add key value pair, and the spring.torque is the name of the metric. So that observability is really a big theme, and a lot of people working on this, making sure that metrics, distributed logs, logs and distributed traces are made consistent. So that's quite an important feature in the next generation. Okay, so the next one is talking about error handling. If you've used Spring Boot, you've already seen the default error handling that we have. So essentially what we do is whenever something occurs, we offer like an HTML, the famous or infamous white label error page that you've seen in your apps, and also a way to translate that to JSON if a client machine is trying to reach to your service. So there's a bunch of properties that you see, the path, which is what triggered the problem, the HTTP status code, some timestamp, and you can see that the message and the error are vague on purpose. By default, we don't try to be smart about exposing the reason of the failure because it might expose some information about the service and it could be a security risk. So we really try to avoid that. And you can, of course, extend from this class. It's a class called error attributes. So you can add more attributes. You can also tune the message based on what you want to do. But it's not as, let's say, it's not as straightforward as it can be. So that's Spring Boot error handling, what we have at the moment. Something else we have at the moment, so that's not new, it's definitely there for a long time. It's the exception handler annotation, which lets you take an exception and then do something with it. So that's the code below there. On that slide, so whenever there's an unknown project exception that's thrown, this method is called, and as you can see, it's returning a response entity. So it's really, you basically are in full control over what the output is going to be. So you can have like JSON, you can have attributes, you can return, I don't know, whatever body you want to return. The problem with this approach is if you want that to be consistent, then you need to build some sort of, library or share utility to make sure that all those responses are going to look alike with the same attributes, and that you can build some sort of API around it. And that's what the problem detail, our RFC is all about. So it's a standard that essentially describe the default output, what the attributes should be, and what they mean. So it's a way for an HTTP API to expose some kind of standard output when an exception happens. And Spring Framework implements, Spring Framework 6 implements .rfc. So this is the difference when you use the problem detail. You get something that looks a bit like what you have in Spring Boot, but it's much more like precise now. You get first of all, you get a dedicated content type. So that's the application problem plus JSON there. So that makes sure that you can do content negotiation, or actually that the client can do something with it because it knows how to handle it. You have a type. So that's the first attribute. And the type is a way for you to provide a location that provides more information about the problem. So let's say you describe your HTTP API and you provide some sort of pages where you explain, okay, when this error occurs, it basically means this and that. So you can provide more context about the exception. You get a title, which is not based on the request itself. So it's really like something that doesn't change for that particular exception. The status code, the instance, so that's the same as what we had in Spring Boot, telling you where that problem comes from. And then you have the detail, and the detail is different from the title, that it actually provides some more information. So it might provide, for instance, the attribute that led to the issue. Okay, so let's give that a try, okay? Let's build a small demo with it. So I have an application here. Doesn't do much. Let me look at this here. Okay. So I'm asking for Spring project. I'm asking for the Spring Boot project. I'm getting like 200 and some, whatever information. And let's take a project that doesn't exist. Then I'm getting, the default exception message from Spring Boot, E500. Some unexpected exception has been raised, and I can see here the error. Okay, so let's try to fix this. So I'm going to create. One way is to create a controller advice. You don't have to do this, right? You could move that method directly in the controller. So if you put it in the controller, essentially that means that any exception in that controller of that type will invoke the method. In this case, it's saying any REST controller, if there is an unknown project exception, then call this. And you can see that rather than returning like anything, exception handler can return a response entity, or you can return headers, or you can return like an object, and it will be serialized as usual by Spring MVC. I'm returning here a problem detail, which is Spring Framework's implementation of the RFC. Okay, so there you get essentially a way to build the problem detail. So I'm going to say, I want to return a form for this. And then it's Pojo style, right? So you can do, I want to say, this website has some information about this problem. Let's say, I want to say the title of project. And some detail about it, like, and I can pass a parameter for this. Then you use the exception to get some context about what the problem was, right? So in this case, the ID of the ID of the exception, the ID of the project, sorry, is part of the exception. So the exception has been designed to add some context. Regardless of problem details, that's very interesting that whenever you throw custom exception, that they contain some info about what the problem was, that lets you reuse it this way. Then the next step is I want to make sure to opt in for this. So the problem details. So I'm basically adding this property, which turns out problem details rather than the default one. All right, so I'm getting now my 4.4 with the detail, instance status title, and the type. Okay, so you're dealing with a problem detail, which has some kind of standard. You return the problem detail, and the rest will be handled for you, like content negotiation and rendering. All right, so the next one is ahead of time transformation and GraalVM native, which is a very, very high demanded feature in the ecosystem. A lot of people are asking for this. So let me go back to how that came to be. So there is a project called Spring Native that was born 3 years ago, where we've started to experiment on supporting native image for Spring-based applications. So we've tried a lot of different ways. So we actually rewrote the whole thing from the ground up several times and got really a lot of interesting feedback from the community. So that was super helpful. And GraalVM itself, so the project was evolving at the same time as we did. So we actually talked to each other and tried to understand how to make that evolve on both ends. So it was actually quite, the timing was quite right. And so after like 3 years plus of experimenting and trying out different approaches, we have now first-class support for that in the next generation of the framework. And I'll show you what that means with some demos. So if you look at Spring Native as a project, it's going to be retired. We won't refer to Spring Native anymore. It will be just native support will be a feature of the ecosystem. So why would you want to try this out, or why would you want to consider it for your applications? So if you look at GraalVM, GraalVM is really a very interesting piece of tech. It's doing like things really changes the game basically for some Java applications. There is some runtime characteristics that you need to take into account. So the fact that in terms of memory efficiency, you change the scale from gigabyte to megabyte. Same for startup time. You have like a few milliseconds startup time, which is like really, really fast. And it also has like predictable startup performance. So because of the nature of building this, you don't get like difference from like just doing compilation on the fly and stuff like that. In terms of why in which use case it might fit, so that it might definitely fit like things like command line interface, serverless, scale to 0. So if you have like services that you want to start when there's traffic, with a JVM based, you can't really make like 0, and when you get a request, just fire up a VM because it might take a few seconds to start. With this, like you get almost instant startup time, so you could definitely scale your services to 0 if you need to be. You can compete with other languages, so Node.js and Golang and tools like that, where it's more suited to certain types of apps and Java wasn't. With a native app, you can reuse essentially what you know already. Don't need to learn a new language. And as we will see, a native image really runs in a constrained environment. You can't, for instance, you can't do like resource loading on the fly without telling it so, or you can't do reflection calls if that wasn't like prepared in advance. So things like they do weird things at runtime, like deserializing object and all kinds of CVs that can lead to that. You don't have that problem with native. Okay, so let's start maybe with a small demo. And what I want to show you is what does it take to get started with this. So the first thing that you need to do is you need to install GraalVM. And if you, oh, sorry, the font here a bit. And you need to install GraalVM 22.3, which was released this week. So it's really on the bleeding edge here. Actually, the RC and the 22.3 version of GraalVM were released the same week or more or less the same week. So it was a bit stressful for both teams. The reason why we did 22.3 is because we're using optimizations that are new in this version. So if you're using an older version, those optimizations will fail. But we thought that with the new generation of a framework, getting the latest as the base was the right call. You can go on the, actually, I was about to say you can go to the GraalVM website, but you can also go here and select GraalVM native support here. So you basically saying, I want to give that a try. And when you do so, there is a bit of like, oh, actually, that's wrong. I should fix this. On the back, interesting. Sorry. So there is a bunch of like additional details about how you can get started, where you can download GraalVM. So if you have SDKman, it's really easy to install it with SDKman. But if you need another way, the GraalVM doc will explain you how to do this. So once you have native image, right, you can build an app locally. There's other ways, but I'm going to show you how to build an image locally first. Okay, so this is a Gradle project that's already, so that's the root of my Gradle project. And I have here the native build tools dependency. My service is basically this app that I've been showing you, where we've built the problem detail. And I'm going to opt in for the native build tool dependency. So this is from the GraalVM team. So they provide a build plugin that manipulates native image and can invoke native image on your app. So once I have that, then I can type, actually, where am I? Yes. And so native compile is a goal from the native build tools dependency I've just added. As you can see, as a result, there's something going on here. There is a new goal called process AOT, process ahead of time. And so what Spring is doing, it's actually inspecting your applications and building a state of your application configuration that is as straightforward as it can, so that native image can optimize it. I'm going to show you in a minute what that means. And the way we do this by generating some code. So that plugin, that process AOT plugin, was automatically applied as a result of adding this plugin, right? So we add native build tools, which means I'm interested by native image, so process AOT runs. If you remove this, process AOT won't run. So it's totally optional, right? It's not like mandatory at all. Well, it's totally optional if you're not building a native image. It's mandatory if you want to build one. Okay, so in generated here, I have like a number of new things. And so that's code that has been generated as a result. So we look at your application, we look at all your beans, we look at the environment. If you have like conditions on things, we evaluate those. And then we dump the context as generated code, okay? And so one thing that's important is if you look at Spring Boot's auto configuration here, if you look at the auto configuration package in Spring Boot, you know it's like very, very long because we support a bunch of things. So these are only the technologies that you've used in your app, right? So the content, HTTP, it's a web app, so it's a web server, sorry. So you have HTTP, Jackson, some WebSocket stuff for the web server, some task auto configuration was enabled, etc., etc. So all the other auto configurations that do not make sense for this app have been removed. So it's not present and GraalVM won't see it. It's very important because if you build a native image with every possible technologies out there, even those that are not in your ClassPass at the moment, the build time will be really long and the image will be huge. So the memory will be more important. So essentially filtering that at build time, make sure that the build time stays small and the image size stays small. All right, so there is some GraalVM stuff here going on. So I'm done with my app. And the application has been built. So let's start it up. That should be this. So yet an app starting in 58 milliseconds. It's the same app as the one you had on the JVM, except it's a native executable now. So let's have a look to actually this service. So this is a native executable for my machine, so macOS x86. If you try to move it to a different CPU, a different architecture, it won't work, right? So that's quite different from the JVM. It's not like you build something and then you ship it around and it will work. But this is the experience of getting started. And as you can see, I didn't have to do anything like telling GraalVM, I'm going to do reflection on this, on that, because it has been inferred by the AOT process. If you're wondering how that would work with Maven, so in Maven, you would do something like this. You would enable a profile called native, and you would invoke the native compile. So that's the command there below. If you're using our parent, we have added a native profile that will take care of enabling AOT, configuring the native build tools plugin for you, etc., etc. All right. So this is really the core of what we do with this new AOT engine. On the left, you have your app, your usual app. So it's been compiled. You have the classes for your code and the resource of your code, like properties and whatnot, everything that your app needs. And we take that, we start the application context in a certain way, where we get essentially the bin factory prepared, conditions evaluated. We get a list of bin definitions that corresponds to what you want to use to your app. And then we generate classes. We generate some code tree. We generate some resources, which are, I'm going to show you. It's metadata for GraalVM. Then we also ask for metadata for third-party libraries. I'm going to get back to that in a minute. And then we compile the code that we've generated, okay? So with all that, so your code and the code that has been generated by AOT, you can essentially go two ways. You can use the way on the top, which is native compile. Native compile is using the native build tools plugin. It will build the native image locally for your CPU architecture. So that's the first way. The second way is to use our existing build packs integration, so the boot build image goal, which will invoke the native image process within a Docker container. Same way as boot build image today can build a container for your app on the JVM. Are they figuring us out already? Light is back almost. There you go. Thank you. Thank you. So you can build today a container with your JVM app, and there are build packs that actually do the same, but for a native image. So you say, okay, I want to build a native image. You use the goal on the middle there, and you don't need to install GraalVM on your machine. And the container can be built for other Arc potentially. That's for native. And then the last one, which we are not like, we haven't been spending a lot of time, but this is going to be a topic for the generations, the feature release to come, is to use that on the JVM. So to run your app with the AOT optimizations on the JVM, which means faster startup time, less memory. It's not there yet because we haven't been really working a lot on. We've been really focusing on native, but that could be an option in the future. So I was talking about the metadata and the libraries metadata thing over there. Let me quickly go back to the project because I forgot to show you this. So with native, if you want to do some runtime reflection, so if you want to invoke a constructor via reflection or method via reflection or loading a class via its name, its fully qualified name, you need to tell it that you're going to do this. There are many cases where GraalVM can see it itself when it inspects your application, but sometimes it can't, and you have to provide some metadata. So for instance, let's have a look to this one. So there is apparently this configuration class, we need to be able to call the constructor, init for the constructor, no, the query the constructor, sorry. And there is also a string HTTP message converter, which takes an environment as a parameter. We need also to be able to introspect it. As you can see, this has been like generated automatically by AOT, so you don't have to worry about it. If you're using a third-party library, the third-party library, if it uses reflection itself, it will also have to provide that metadata. So either the library provides that directly, or they don't. And if they don't, someone has to do the work. And GraalVM has an open source centralized repository on GitHub where you can contribute those hints. So let's say you use, I don't know, let's take an example with Jackson or Netty. Well, Netty is not a good example because they ship it. Let's say Jackson does some reflection. Then there is, in that repo for Jackson classes that do reflection, there is those entries being generated and every project can benefit from it. So that's for reflection. There's also resource loading. So you can't load a file in a native image unless you actually said so. The reason why is because the content of the file is not going to be shipped, added in the native image. You need to ask it explicitly. So you can see, for instance, here, so that's a regular expression if you're wondering about the Q and the E there. It's an exact match. So Spring Framework is loading this file to get the MIME types. We could have like moved that to code generation, but we haven't done so yet. All your application config here, we automatically like add hints for that. And so if they are present, they're going to be shipped in a native image and can be loaded this way. So concretely, AOT phase in Spring, what it does, it looks at your configuration class, it parses them, it generates some source code so that you can easily look at the output. You can also debug the output if needs to be. And it simplifies what GraalVM does a lot, because rather than GraalVM having to, maybe I should first say what GraalVM does. So at build time, what GraalVM does, it's executing your app, all potential code paths of your app and analyzing it, right? So it's trying to figure out it is figuring out all the code paths that your application can take and generate the native bytecode that corresponds to that. So it's really, really smart. But if you have a lot of code paths, this can take a lot of time and a lot of CPU. So this phase is essentially, rather than telling it, oh, we have the configuration class parser and it can do this and that, we remove that entirely. And we say, when you need to start the app, this is the code that you need to invoke. Which is summarized in here. So you get a fixed class path, a fixed environment. So it's much more restrictive than a JVM-based application. You can't add a library on the fly with a native image. Once the native image has been compiled with a given class path, it can't change. You can't add a resource. There is no notion of file system in GraalVM. So it's much more restrictive than an application on the JVM. So you have a fixed class path, a fixed environment. There's a main class that you need to invoke. And then what we do is we simplify the process of creating the app by parsing your configuration, generating code, generating hints, and then we pass that to the GraalVM native image compiler. Okay, so if you want to get started with this, there is a few recent blog posts about it. As usual, if you go to start.spring.io, you pick up GraalVM native support. You can also, let's have a look to Maven. So if we look at Maven, you'll see that you also get oh no, the bug, damn it, that is wrong. Oh boy, interesting. Nobody told me that. So I'm looking at that page and I already found 2 issues. Okay, sorry. So that's a native semicolon compile not package. I need to fix this. But anyway, sorry. Then you have like links to how you can get started, install Docker if you want to opt in for Docker, or install GraalVM if you want to try it out locally, etc. The last feature for today's session is Java interface clients. So Java interface clients are meant to simplify how you build clients. And this is one of the examples, something that you may have to do, right? So you need to contact a service. You need to get the project summary from this service. Sorry, a Spring project summary from that service. So you use the REST template or the web client. You say, okay, I need to invoke this. You pass some headers or some cookies or whatever needs to be set. And so you have to write this over and over again. And we felt that there might be a way to simplify that. And one way to simplify that is actually to write an interface and to provide some information that look a bit like what you do on the server, but a bit different. So what you would do on the server for answering that request, you would use the path variable, yes, and you would use get mapping or request mapping with some like information about what the server would accept, what it produces, etc. And then returning an object and making sure that that thing is serialized by Spring MVC or Spring Webflex. On the client, you can see it's called get exchange. But the path variable was kept. So what we've tried to do is to make sure that annotations that make sense on the client are kept. So it's the usual annotation you use on the server essentially, because the meaning it has is the same meaning. So we can use it both on the client and the server. For the annotations that are contain like server specific features, then we created a dedicated annotation. So in this case, get exchange. Right, so let's have a look to how I can build this. I have a CLI here, which doesn't do much. Actually, doesn't do anything at the moment. And I'm going to write a client for the service. The service that's still running, it doesn't. Let's make sure it's running. The service that we've built as a native image. Okay, so first thing I want to do is create a basic interface for what I want to invoke on the server. And I want to say, I want to be able to invoke Spring projects with that variable, and that variable is mapped to this. Okay. If you look at getExchange, you can see it has like additional values over there. And I'm returning a project summary, which is like ID and name. And ID and name is, let's have a look to this guy. This is this output. Okay. So now I need to turn that interface into an actual client that do something. So to be able to do that, I need to expose a few beans. So the first bean, and because I'm lazy, I'm going to do this. It's going to be easier. The new interface, the new feature that we've created in Spring Framework 6 for this is called HTTP Service Proxy Factory. It's something that can create a client, in this case, an HTTP client based on an interface. So for that, I need to give it some actual web client it can use. So this is what I'm doing here. I'm saying, please build a client for me on, in this case, for the demo on localhost 8080. And that web client builder has been auto-configured by Spring Boot. So all kinds of, if we've detected you use Jackson, we configure Jackson automatically and codec that are needed, etc. Once I have that, I have a client adapter. I can create a proxy factory for it. Then the next step is to actually build my, how is it called again? My Spring projects client. And I'm actually using the HTTP service proxy factory that I've just built below. And it's as simple as doing this. Right. Then I have a bean. And let's use it. And I can say, actually, project summary, Spring Boot. And let's output that. Read it through the builder. Oh yeah, I can't do that. Oh, that API has changed since the last release. Am I going to debug that now? Aha. So I'm going to cheat instead. I'm going to explain what I'm doing in a minute, just making sure that it actually works. There we go. So this is some feedback actually we've provided, that it was a bit strange that the service proxy factory is actually created for one specific target. It would be nicer if we had a way to configure the proxy factory and then give it a client after that. So that's why the API has changed. There is now a builder that you can use, which is this thing here, and expose the builder as a bean the same way as the web client is exposed as a bean. So you inject the builder instead of the object, and then you can customize it for whatever need you have. But anyway, the outcome is this, right? So I get my project summary. And if I look at the code here, it's actually, sorry, if I need to look at the code here, it's really calling the interface. So that has been automatically translated to an HTTP client. There is a number of additional annotation you can use. For instance, you can set request headers. You can share request headers for every call on the interface by putting it on the interface itself, or you can put it on dedicated exchange call. It's really up to you how to design your client. And the slide was about clients with an S. That's because we do also have support for RSocket. As you can see, RSocket exchange. So same thing, if you want an RSocket client, you can use also this facility. It's an RSocket RSocket service factory instead of an HTTP service proxy factory. But the system remains the same. Something also I did not mention, but as usual, if you've been using Spring Data or any other such feature, you know that the signature is quite flexible, so you can return different return types, and we'll look at that and infer it automatically. So if you want the API to be non-blocking, you can actually, rather than returning a project summary, you can return a mono of project summary. If you're only interested by the HTTP header for whatever reason, you can do that and we'll automatically expose the right thing. And if you have a post exchange, you can also have void because you just want to make sure it worked, but you don't need to get any result out of it. All right, so there's 2 minutes left and I'm done. I don't know if there is any question or if you want to, for those who are on site, there's Belgian chocolates. So if you're missing out, I'm sorry. That's it.
Okay. Is there any question?
Sure.
So I want to ask about the Spring Cloud. I understand the restoring of Spring Cloud and the Spring Boot is separated. So, and the bottom file version of the Spring Cloud is now 2021.4, as I remember. So I want to ask, when will the next Spring Cloud will be released for Spring Boot 3.0?
So the question is, Spring Cloud has a different release schedule than Spring Boot, and we've been talking about Spring Boot 3, but what about Spring Cloud? When will it be released? So actually, that's a good question. Let's find out if they have that here. So the current milestone for Spring Cloud is M5. So that's the release train that will go with Spring Boot 3, 2022.0 M5. There is also an application that's called the calendar, so calendar.spring.io, where we expose our release dates. So let's have a look to maybe if they have like scheduled that already or not. So you can see the schedule for the GA here. There you go, 22. So on November 30. So that will be 2 weeks, actually 1 week after Spring Boot 3. Spring Boot 3 is here.
Oh, yeah.
And Spring Cloud is here. So it's one week after.
Ah, I see. Thank you.
Can I ask a question?
Of course you can.
About Java interface client. Is it support to resiliency function like
yes. So does it support like Resilient4j or any resilience mechanism via the Java interface client? It's actually a very good question. I forgot to mention some of the history behind this. For those of you using Spring Cloud and OpenFeign or something where you also have this ability of retrying things or provide like a load balancing or any extra feature you get automatically for of your clients. This feature actually came from Spring Cloud. So initially Spring Cloud wanted to implement something like this in Spring Cloud itself. And then we've realized that in Spring Framework, we had like also such a feature, such a need. And so we worked with the Spring Cloud team to share that effort. So everything that's load balancing, resilient for J, all that will work with this in the next, the Spring Cloud release we've been talking about. They've basically rebuilt everything on top of this.
Okay. One more question.
Sure.
When creating native image, I recognize we can't use profile to switch configuration runtime at runtime. So we should build native image for each profile.
Okay, I got your question. So the question is about profile in native images. And let's go back to what I was saying about the environment, which is this, right? So the environment is fixed and conditions are evaluated. So what about I have a profile to switch some values? Will it work with a native image? The answer is it depends. Something that you won't be able to do is adding new beans or removing some beans based on the profile. So typically, let's say you want to expose additional actuator endpoints, for instance, or you have like some kind of something that enabled property that you can use to opt in for certain features. That won't work because you won't be able to change that at runtime without recompiling the native image. Because what we do is we generate the beans and all the conditions are evaluated at build time. So you can specify the profile at build time you want to use, and it will be taken into account. So there is a way to specify the profile when AOT runs, and that will work. The thing that will work without recompiling is if you have a profile, for instance, to connect to a certain database, and then in production, you connect to a different database. So you have like properties to switch to a different database, but you always connect to a database. That will work because that's really about configuring the bean. It's not adding a new bean. So in a nutshell, configuration that impacts the application context, that won't work. You will need to set it at build time. Properties that lets you configure an existing bean, that will work. So for instance, let's say something I can do to show you what that means in concretely is I have my native image here, and let's say I want to start it to a different port, then that works, right? I don't need to recompile the native image. I'm saying I want this port. It's a property that it's starting a server, but a different server. Now, if you're saying I want to have the actuator now, there's no endpoint exposed, but I want to expose some endpoints, that won't work because the endpoint is a bean and the bean has been determined at build time. So you can't do that.
大丈夫ですかね。ツイッターに質問とかないですか。
One more question. So,
Sure.
as a Java interface client, what protocol does the Java interface client support? So, you show HTTP and RSocket.
Yes.
Can I use it for M2P or?
There is a chance that it will come. Yes. There is a GraphQL one in the works.
Right.
So Spring for GraphQL, the team mentioned that they wanted to offer such a client. I wouldn't be surprised if we started to see things like for messaging and stuff. I don't know if they're already considering it, but if you feel that it would be useful, you can also create an issue. So you can go to Spring RabbitMQ and say, hey, I would like a client for this and see what happens.
I see. Thank you.
大丈夫ですかね。
All right. Thank you for your attention. Thank you.
Thank you. はい、じゃあ勉強会は以上に、したいと思います。お忙しいところありがとうございました。じゃあ終了します。
ありがとうございました。
ありがとうございました。